I would like to welcome you this evening to our Ocean Tipping Points panel. We're very excited to have our panel here to talk about this really very cool project that is in partnership with the Center for Ocean Solutions. Before we get going, I want to remind you that this is a marine event, so we do have Emma at the back there who's live tweeting the event. So if you do follow Twitter, then we are at COS_marine. I'm going to put it right there. So you can follow along, or you can tag us if you would like to. We use hashtag marine event, which is kind of obvious, but easy nonetheless. Marine is a professional development program for graduate students and early career professionals in the Monterey Bay area. It is a collaboration between the Center for Ocean Solutions and 7 Monterey Bay area campuses. Each of you in this room represent those campuses, and we also have a couple of extra visitors here this evening, which hopefully you've got to know from your Ask Me tags that you've been wearing. Nobody asked me about mine yet. You should make sure you do that. If you've never participated in Marine before, thank you very much for coming this evening. We would like to see you back at future events. We run a variety of different opportunities, not just panels and seminars. We do a variety of different leadership development workshops in relevance to things like communication, collaboration, and developing innovation, which is very cool. We rotate those activities between our 7 campuses in the Monterey Bay area. So sometimes they're down here in Monterey, sometimes they're up at UC Santa Cruz, sometimes they're up at Stanford. So do keep an eye out for that. If you'd like to keep in touch with all the different marine activities that we put together, then I would encourage you to go to our website at centerforoceansolutions.org/marine, which I'll write up at the end of the session. There is a newsletter there that you can sign up for that will keep you in touch. It'll also keep you in touch with everything else going on in the region that's to do with the oceans. We like to stay in touch with all of our partner organizations, which includes the Monterey Bay Aquarium, the Monterey Bay Aquarium Research Institute, and of course Stanford Woods Institute for the Environment. So there's lots of different things available on there that you can take a look at that we ourselves may not facilitate, but we try and get you guys to take a look at those opportunities if they pertain to the type of work that you do. Hopefully you've had a chance to network. If you had your conversation interrupted to come down here, make sure you finish that conversation before you leave this room this evening. Everybody in this room is your peers. They may be your peers for many years to come, so it's a really good opportunity to get to know other different ocean disciplines that are in the room. And there's all sorts of folks. There's policy folks here, there's social science folks, there's natural science. So please do you get to know those people as much as you can. And last but not least, you'll notice with all of our different panel talks, we are talking about an overarching theme of interdisciplinary collaboration. So I want you to keep in mind and be open-minded about how our panelists communicate. They may or may not use visuals. They may talk about different components to this project in perhaps different ways than you are used to. So I encourage you to ask questions when we have the opportunity to. And you are welcome to jot those questions down as we go and save them up for when our Q&A time is. So without further ado, I would like to introduce the moderator of this very interesting panel this evening. I'd like to introduce Dr. Carrie Capel. Carrie is an associate project scientist at the National Center for Ecological Analysis at UC Santa Barbara. And she's also the lead for this Ocean Tipping Points project. And this project is actually aimed at integrating a growing understanding of tipping points in marine ecosystems in decision-making tools to enhance resource management. So it's right at the interface between science and policy. It's very much about knowledge to action. Carrie is a marine conservation biologist and community ecologist, which will relate to many of you in this room. Carrie received her PhD from right here from Stanford University in biology. And the major themes of her work include quantifying the ways humans depend upon and impact marine species, habitats, and ecosystems, understanding the spatial distribution of ecological and human components of ecosystems in order to inform conservation and management, and developing ways to integrate biophysical and socioeconomic data to support environmental decision-making in coastal ecosystems. So super, super interesting work that many of you may very well be doing some work that's related to yourselves. And her research has mostly been aimed at informing marine protected area design, ecosystem-based management, and marine spatial planning. So I would encourage you to get to know Carrie throughout this evening. So without further ado, I'd like to welcome Carrie up to the podium. Thank you very much.
Thanks. Thanks, Laura, so much. It's really fun to be back here. Thank you for the invitation. The last time I stood on this stage, it was for my practice talk for my thesis defense 10 years ago, so it's fun to be back here. And I thought I would start by just introducing my co-conspirators on this panel and give you a little bit of a foreshadowing of what we're going to try to do tonight. So I'm going to start out by just giving you the broad brush introduction to the Ocean Tipping Points Project and what we're all about and how we're trying to take science to action. And then we'll do a little bit of a deep dive into our 2 case studies in Haida Gwaii and in Hawaii, and then talk about the policy and engagement with the policy research and engagement with managers that we're doing all along the way in the project, and then some big picture lessons learned about this process of trying to take science to action. So I will be joined up here shortly by Rebecca Martone, who's up here in the front. Probably most of you know Becca. Becca is the Assistant Director for Science and Research at the Center for Ocean Solutions. She and I both came out of Theo McKelly's lab here at Hopkins, and it's just a joy to be able to be working together on a project again after all these years. Becca has a PhD in marine community ecology and has worked in kelp forest systems from Baja up to British Columbia. Has a deep knowledge of both the natural history and ecology of those systems, but also the policy and management actions that can make a difference in them and in other systems as well. And she's doing great work at the center. Ashley Erickson is going to bring us the law and policy perspective. Ashley and Becca are like the dynamic duo at the center. Ashley is the Assistant Director for Law and Policy. She's got a JD from UNC Chapel Hill and brings a really deep understanding of marine and coastal policy to the work that we do and all the work that the center does. And she also has just amazing skills with working with people and engaging with managers, and that kind of outreach expertise has been really critical in our project. And then Rod Fujita here is one of our co-PIs on the Ocean Tipping Points project from the Environmental Defense Fund, and Rod is their Director of Research and Development for the Oceans Program at EDF, where he's been leading the charge on really innovative market-based solutions to fisheries problems and conservation issues for decades. And he not only has training as a marine ecologist, a PhD marine ecologist working in lots of different systems, but also has really been bringing this interesting and innovative lens of what makes people tick. What is it that's really going to change their behavior, and then how can we use that to lead to change on the water? His perspective has been just critical for all the work that we're doing for Ocean Tipping Points. So I'm really excited that we can be here together tonight to talk to you about what we've been doing, and I really welcome your questions. The way we're going to do this, though, is a little bit of a rapid-fire, quick-paced set of presentations with a little bit of time to stop and just think in between, jot down a couple questions, but we're going to actually ask you to save your questions until after we go through each of these short presentations. And they're just 10 minutes long, so. And then we'll really get to have a meatier discussion, both about the science and also about this experiment in taking science to action that we've been engaged in. So I want to start by acknowledging the research team, which is huge. And I'm sure I've missed people. I know there are folks from the center and who have helped with this who aren't on the list. So apologies if I've missed anyone. But you'll see it's a multi-institution collaboration between UCSB, NOAA, Stanford, EDF, Cal Poly, University of Hawaii, Stockholm Resilience Center, as well as our partners, the management agencies in our case study regions. So it's a big collaborative effort and an interdisciplinary one involving both natural scientists and law and policy experts and social scientists and practitioners. So I'm going to dive right into what we mean by ocean tipping points. and start there so that we all have a kind of a common understanding of how we've been approaching it as a project. So the working definition that we've used is that an ocean tipping point occurs when a small change, an incremental change in either environmental conditions or human use of the environment leads to a big change in the system. And that large change can sometimes have real consequences for people. And for those of you who maybe have spent some time thinking about nonlinearities in ecological systems or in social systems, I want to be a little more specific about what we mean by that. We have really tried in this project to be pretty agnostic about theory. We're being inclusive in that definition for a reason. So we're including not only, so just to back up, there are a variety of different ecosystem kind of dynamics that can lead to what looks like an abrupt change in the state of the system. And people have tried to classify those into different types based on what's going on in the relationship between the driver that's causing the change and the response of the ecosystem. So this classic paper from 2004 from Colley shows 3 different ways that you could get an abrupt change in the ecosystem. So each of these are time series data of a population abundance and an environmental driver changing through time. And you can see these boom-bust cycles, right? These are abrupt and really dramatic changes. But underlying that, there could be a linear relationship between the driver and the ecosystem response, and it's just that the ecosystem is tracking that driver. And the driver itself is changing in a nonlinear fashion. Or it could be that there's some kind of threshold response. Once that driver gets past a certain point, then the population crashes. Or you could have this kind of a response where you have that threshold, but then once you fall off that cliff, you can't just reverse it. You can't just climb back up there. You actually have to shift the system back to a much lower level before you can get back up to this part of the curve. And that's something that theoreticians call hysteresis. But any one of these abrupt transitions has important implications for managers because it looks like all of a sudden the system is operating by different rules. And we have, and in practice, these are really hard to distinguish in the real world. It takes a lot of analysis to actually, and a lot of data to be able to tease out which one of those you're seeing. So in the project, we've tried to be pretty inclusive and to also offer methods and analytical approaches for separating these and understanding what's going on behind the scenes. Okay, so there are examples of these kinds of tipping points from all around the world and from a wide variety of marine ecosystem types. Some of the classics are the shift from abundant kelp forest to urchin barren, driven by the removal of predators and the overabundance of the herbivores, or a shift from coral-dominated to algal-dominated reefs, or collapses of fishery systems. So we've done some work to characterize these and synthesize the examples from around the world and found a wide range of examples, nearly 100 cases that we can document. And we're starting to learn from this database of shifts. Across that whole set, the big drivers of these things tend to be overharvest, eutrophication, and climate. And those are often really acting in concert. And once a tipping point has been crossed, these shifts can be persistent for quite a long time. Most of the examples in our database represented shifts that lasted for decades. And while not all authors provide a really robust test of how reversible those shifts are, the evidence suggests that recovery, when possible, will take years to decades. So that's really the motivation for us in approaching this project. We know that the shifts are common, that they can have big consequences, and they can be difficult to reverse. So we've been attempting to bring a wide set of tools to bear on the problem of both enhancing knowledge of why and when and how these shifts occur, and then trying to connect it to tools that managers can really use. So I just want to walk you through a few of these little cartoons that kind of lay out what our approach to the suggest that maybe it's one potential model for taking science to action, particularly in the service of ecosystem-based management. So ecosystem-based management has as its goal healthy, productive, resilient ecosystems that can sustain benefits to people, but abrupt changes in the structure and function of the ecosystem can impede those or undermine those goals. And so our hope is to try to bring some tools that can address that problem, but doing that has been really challenging in the past. There are all kinds of issues like the lack of good tools, sort of underlying assumptions about linearity, a lack of predictability that have made that really hard. So our project really aims to both advance knowledge and understanding of tipping points, keep moving the science along, and also try to connect it to a set of tested tools and resources and analytical approaches that people could use in the real world to try to anticipate, avoid, or respond to undesirable tipping points in their systems. And we're using a pretty collaborative approach to do that and to generate the questions that guide the work. So the questions that we're tackling were all really generated through this dialogue between our team, the larger scientific community, and our partners, our case study partners, and a group of management advisors who Ashley's going to talk a little bit more about later. And so they've been engaged with us from the beginning and have really informed how the work has developed. And the strategies that we're using to draw on, they draw on our team's core strengths, but they're really intended to work together to produce useful science that will be taken up by the managers. So we've been, particularly in the earlier phases of the project, synthesizing global data and examples, trying to analyze what works in threshold-based management from places around the world, identifying appropriate legal and policy vehicles where this science could be taken up, and then working with our partners in our case study regions to co-develop approaches that would work for them. And all the time being in this communication loop with the managers so we get feedback from them. And we really feel like there's an opportunity here to improve management. Over the past 5 or 10 years, there's been just an explosion of new research in this area. Much of it which is really exciting and tantalizing for its potential to inform management, like the development of potential early warning indicators of these tipping points. And so that sort of burgeoning of the scientific literature and the set of analytical tools and the computing power that's out there is coming together with a paradigm shift towards thinking more about ecosystem level challenges and management approaches. And so I think that's really the crux of what we're trying to bring science to action. Some of the legal review work that we've done in the first phase of the project, which Ashley will probably talk a little bit about, shows there's plenty of scope for doing this. The existing U.S. environmental laws all support and allow for the use of thresholds, which would come out of tipping point-based science. So that's promising. And the work we've done to synthesize across examples from around the world also shows that the more you do that, the better the results you get. And Ashley's going to dig into that a little bit more later in her talk. That synthesis also suggests that preventing a shift is likely to be less costly than trying to recover from one. And that just makes basic sense. The costs of restoration are really high, and it can be extremely challenging to actually move a system back. But if, as we are in many marine ecosystems around the world, you are in that case of having experienced an undesirable tipping point, then understanding what were the drivers of that shift and what are the feedback mechanisms that are keeping you in that new state can really help prioritize the appropriate management actions and give you a target for how far you need to move the system to get back to a more desirable state. So I'm going to segue now to the case studies because I think they highlight how we're starting to try to apply this work, and we'll give you a little taste of the science that we're doing. Both our case studies really let us test and refine these ideas in a real-world context. They both have interesting tipping points that lead to interesting questions and important policy windows where we had managers on the other side saying, yeah, we need this stuff now, and we will work with you to develop it.